In today's lesson, you will learn how to solve inequalities involving dividing by a negative and how to solve some inequalities involving fractions. By the end of this lesson, you should be able to solve inequalities involving fractions and when you need to divide by a negative. Some previous knowledge you will require is you should be able to solve equations involving the x term on both sides. You should be able to solve equations involving fractions, and you should be able to identify and solve inequalities involving more than one step. So we're going to look at really some tricky questions today, so I want you to be really confident in the previous knowledge before you try this lesson. So we're going to look at the main difference between solving equations and solving inequalities, and that's what happens when you divide by a negative. When you divide throughout an inequality by a negative number, the sign flips. So if it was a less than, it becomes a greater than. If it was a greater than or equal to, it becomes a less than or equal to. And we're going to look at a few examples of this. So we're being asked to solve here some very similar questions. However, the answer is going to change depending on whether we need to divide by a negative or not. So the first one, 3 is multiplying by x. 3 is not a negative number. We are dividing by a positive 3 here. Nothing needs to happen to the sign. We're dividing by a positive number, so we know that x is less than or equal to 3. In part B, although the 9 is negative, we're not going to have to divide by the 9. It's the 3 that is multiplying the x, so again we are dividing by a positive number, leaving us with x is less than or equal to. Negative divided by a positive is a negative. 9 divided by 3 is 3. So our answer is negative, but nothing has had to happen to the sign because the number we divided by was positive, the same as in part A. Now look what happens in part C. This time it's a negative 3 multiplying by the x. So when we divide each side, we are dividing by a negative number. In this instance, the sign is going to flip. So what is currently a less than or equal to sign is going to become a greater than or equal to sign. So x is going to become greater than or equal to 9 divided by negative 3 is negative 3. And the sign flips because we divided by a negative number. In part D, again, it is a negative number multiplying the x. We are having to divide by a negative 3 on each side. So we are going to have to flip that sign. That leaves us with x is now greater than or equal to negative divided by a negative is a positive 3. Okay, so you can notice the difference between A to D depending on whether we are dividing by a negative. Okay, let's look at the negative x term and some more difficult examples then. So we now have a solve involving more than one step. So we're going to have to apply our BODMAS in reverse. Anything adding or subtracting the x term we're going to deal with first. Plus 16, we're going to subtract 16 from either side. That leaves us with negative 5x is greater than 46, take away 16 is 30. It is a negative number multiplying the x, so we need to divide each side by negative 5. Because it is an inequality, the sign flips direction when we are dividing by a negative. That leaves me with x is less than 30 divided by negative 5 is negative 6. In part B, 10 is subtracting from the x term, so we're going to add 10 to either side. That leaves me with negative 3x is greater than or equal to negative 13 plus 10 gives me negative 3. It is a negative 3 multiplying the x, so we're going to have to divide each side by a negative number, which means that sign is going to flip to less than or equal to. That leaves me with x, negative divided by a negative is a positive, 3 divided by 3 is 1. So x is less than or equal to 1. Okay, we've got quite a lot going on here in example 3. So we've got some brackets that we need to multiply out and we've got an x term on the right hand side. So let's begin by multiplying out that first bracket. 2 times x is 2x, 2 times negative 5 is negative 10. And we're keeping everything else the same for now. Now we've got a 5x on the right hand side of the less than or equal to sign. We don't want it to be there. We want to get rid of that. So we're going to subtract 5x from either side. That leaves me with 2x take away 5x is negative 3x. Take away 10 is less than or equal to, and all we've got left on the right hand side now is 11. The 10 is subtracting away from the x term, so we're going to add 10 to either side. That leaves me with negative 3x is less than or equal to 21. It is a negative number multiplying, so we divide by a negative number and we flip the sign. So this becomes a greater than or equal to sign. That leaves me with x is greater than or equal to positive 21 divided by negative 3 gives me negative 7. In part B, very similar, we're going to begin by multiplying out the brackets. 6 times x is 6x, 6 times 2 is 12. Everything stays the same. The 7x is on the right hand side of the less than sign. I'm going to subtract that away from each side, which leaves me with negative x plus 12 is less than 2. 12 is adding the x term, so I'm going to subtract 12 from either side, leaving me with negative x is less than negative 10. There's a negative 1 in front of that x, so we are dividing by a negative number, which means our sign is going to flip, leaving me with x is greater than positive 10. Okay, in example 4, we're not looking at examples where we need to divide throughout by a negative. I just wanted to throw in some of these tricky fraction questions. So remember when we were solving equations that involve fractions, we multiplied throughout by the denominator so that we could get rid of the fraction that is on the bottom, okay? Now, because this is in brackets, that is all the one term just now. So when we multiply everything by 2, the denominator of this fraction, we don't multiply the 4 because the fact that half is going to multiply throughout accounts for multiplying everything by 2. So in 4a, we are going to cancel the 2 that is multiplying and the 2 that is dividing, which leaves me with 1 times in the bracket of x minus 4. We've got our less than or equal to sign, and then 2 times 7 gives me 14. That's just the same as writing x minus 4 is less than or equal to 14. To get x on its own, we'd need to add 4 to either side. X must then be less than 14 plus 4 is 18. Now, if I had multiplied out my bracket there first by the half, we would have had a half x take away a half of 4 is 2 is less than or equal to 7. And then we would have had to multiply everything by 2. Now that the bracket is broken, that would have given me x minus 4 is less than or equal to 14. So we would have got there the same way. In part B, there's no bracket, so everything's getting multiplied by 3. Times 3 cancels with the divide by 3, leaving us with x plus 3 5s are 15 is greater than or equal to 10 3s are 30. 15 is adding the x, so we need to subtract 15 away from either side. And that leaves me with x is greater than or equal to 15.